Yes, we apologize for the technical issues. Finally, we're ready to proceed, and the next presentation will be delivered by Yuri Antantek. He will be presenting extracting text representations from pre-trained language models via edit distance-based loss function. And Yuri was supervised by Serhiy Havrelov. Yuri, it's the best of luck.
Thanks. Glory to Jesus Christ. I'm Yuri, and Ruslan already told the uh, topic of my master thesis. So the agenda for the talk will be the following. I will give a brief introduction about what are text embeddings. Then we will describe the chosen approach for extracting embeddings from pre-trained language models, and we would suggest and potential enhancement to this approach. Then we will present setup and results with experiments and give the directions for future work. Um, yeah, we all know what are text embeddings. Basically, it is a way to represent some piece of text or anything else as a dense fixed length vector. And in order for the embedding to be useful, it should capture semantics of the text. Um, it can be used for features for downstream tasks. It also can be used for compression, although not it may not be applicable to NLP in particular very much, but in other fields we can do compression. And what's applicable in NLP, we can solve the problem of semantic search, meaning that the problem of semantic search is a problem of finding the set of relevant documents to the input document. So you have a input document and you need to find the selection of relevant documents. And if you have explicit embeddings, then this problem is easy to solve, even if the number of documents is huge. Um, yeah, so a few traditional approaches. So word2vec is like the first one of the first approaches, and they trained embeddings with the idea that similar words are used in similar context. So um, we train embedding in such a way that the embedding for the word is close to the embedding of its context. And these kind of embeddings possess good semantic and syntactic qualities, but they lack contextual information, meaning that embedding for the word stays the same regardless of the context it is used in. And it's not particularly clear how to define a sequence embedding in such a way. So you can average the embedding for the words, but it may not be optimal because by doing this, you don't consider the order of the words, etc. Another more recent approach to this is using autoencoders. So the basic idea is that we assume the existence of a latent space from which the observation may be fully reconstructed. And because so we have encoder and decoder neural networks, and because we introduce a bottleneck, we force the model to learn this embedding Z, and this embedding Z should be useful to do reconstruction. Um, so the plus of this approach is that it explicitly models the latent space, but the minus is that it's not popular today and it's not the focus of attention. What is focus of attention nowadays are transformers. And for example, so this is not a very recent transformer, but still, if you consider BERT, which is encoder-only transformer, it's not particularly clear and or well defined on how do we receive an embedding for an input text. So what we can do, so we can just use activations from the last layer of BERT, but it's not clear why we should only use activation from the last layer. Should we consider like activations from the two of the last layers, or three or four? How should we combine them? In what way? How we should combine the embeddings from the words to get the embedding for the sequence, etc. And this is still kind of an open question in the sense that it is not standardized across downstream tasks, meaning that for each downstream task, we need to consider different combinations of combining these outputs. And it was shown in some papers that the performance will degrade significantly if this problem will not be properly attributed. But maybe we don't need embeddings at all because for now state-of-the-art models, they simply fine-tune the pre-trained BERT to solve the downstream tasks in an end-to-end fashion. So maybe we don't need embeddings. But if you consider compression and semantic search, we will still need explicit embeddings to solve this task. So there are tasks where you cannot really do fine-tuning. Yeah, so for example, yes, there were attempts to solve semantic search using pre-trained transformers, but they didn't model embeddings explicitly, and they used transformers only for re-ranking purposes. So they used previous like older models for retrieving a large set of relevant documents, and transformers were only used to re-rank this the relevant documents. So because the number of relevant documents were drastically reduced, we can use transformers in fine-tuning setup to further improve semantic search, but we still desire an explicit embeddings and explicit high-quality embeddings in order like to solve semantic search properly. So the question that we ask is whether we can extract embeddings from a pre-trained language model. And this possesses a few challenges. So the first challenge is that we would like to attribute the fact that current embedding approaches are not uniform. So we would like embeddings to be suitable for multiple downstream tasks, which means we don't want fine-tuning and additional data. Second challenge is that the language model may not model embeddings explicitly as it is in, so if you compare, for example, autoencoder to transformers, in autoencoding we have explicit embedding modeling. And the third challenge is that present approaches either fine-tune the model or change the architecture of the model, which is both of these points are not ideal, because if you change the architecture of the model, you need to retrain from scratch, and if you fine-tune that, you need to fine-tune on multiple downstream tasks. Yes, now for the approach that we would like to study. Just a brief recap on language modeling setup. So basically, we have a data set of sentences, and we want to train the language model which maximize the expected probability of sentence from the data set. Yeah, I guess I can skip it because like it's you all know this. So then we stumbled upon the paper which was this name, and it studies the problem of existence of sentence representation space vectors from which can be used to reconstruct the original sentence. So basically you have this language model. This language model is pre-trained and frozen, and this paper studies the way to condition the language model based on like to condition the language model which was not trained to be conditioned, so to say. So they say that we have this input sentence X. For this input sentence X, we have an embedding Z. And this embedding is found in such a way that it maximizes the probability of this input sentence, which is reported by the pre-trained language model when it is conditioned on this vector Z. So for a recurrent neural network as here, this is LSTM, I guess, the conditioning is done by injecting this vector on the first as a first hidden state, as well as adding this vector to every hidden state along the way. And basically we only train this vector to maximize the probability of the input sentence, which is reported by the language model when it is conditioned with this vector Z. This approach has its pros and cons. So its biggest pro is that we don't need any additional data. So we only need this input sentence for which we want to compute the embedding. And There was also a paper which explored similar stuff for transformers, for conditioning transformers. So the cons of this approach is that each sentence requires this embedding vector to be trained. So for each sentence you need to solve this optimization problem. And with LSTM in particular, this problem, this paper has reported difficulties with recovering longer sequences. So basically, when you recover the sequence, as long as you miss the token during reconstruction, further reconstruction fails. And also the quality of these embeddings need kind of further assessments. It is not like widely used, and this paper didn't say anything about like applicability of these embeddings in real life. Um, Yes. So if we think about the problem of reconstruction, why it might be happening is because we like hypothesize that the potential problem to this might be exposure bias. What is exposure bias? It means that model is trained on ground truth data, but when we do reconstruction, it should generate its own data during inference, and because of this, we end up with two different distributions of tokens, which model sees during training and during generation. Yeah, so to illustrate this, when we the green when we train this embedding vector Z, we feed the ground truth sentence to the model as is. And but when we do reconstruction based on this vector, we provide this first token, which is beginning of sequence, and we sample from the distribution of the next token and feed the sample token. And there is no guarantee that during reconstruction, this x1 hat will be the same as a ground truth token at the same timestamp, meaning that at some point it will differ. So the sampled token will differ from ground truth, and because of this, further tokens that will be fed into the language model will differ from the tokens that the model was trained on, and we can say that this embedding was trained during reconstruction. The data that we pass to the model differs from what it was during training. It may cause a confusion for this embedding vector. It has some background with control theory, and namely the problem of distributional shift in behavior cloning. So if you consider some agent in the real world, for example, like self-driving car, it has some sensors, so it observes the world, and at each time point t, it needs to provide some steering commands for this to for car to drive, and based on this action, it ends up in different state, and observation changes. So if we just train it using a supervised approach, it will not work because the expected trajectory of states that model was trained on
No, it's story, so the usually is just is a project when the people
Yeah, okay, so I will continue. So basically, by doing supervised approach, it will not work because the actual trajectory, which is red, will differ from the training trajectory black because of the error which is accumulated during a prediction of the actions. And in our case, our training trajectory is ground truth sentence, and our observed trajectory is the generated sentence. And one of the ways how we can mitigate this issue is by using dataset aggregation. So basically, we train supervised policy, we deploy it into the real world, we observe it fail, and we take a human expert and we ask him to assess what should be done in this particular scenario of the run of the policy in the real world. And this additional data is used together with initial data to enhance the data set, and given enough iterations, such policy will work. So we have stumbled with the paper about optimal completion distillation for sequence learning, and it explored the same setup for in case of NLP. So basically, if you are given sample sentence and if you are given ground truth sentence at a particular time step, we need to somehow define the tokens that should be generated in order to move back from the wrong trajectory and continue on the ground truth trajectory. So, for example, in this particular case, on the vertical axis, you see the generated sequence, and on the horizontal axis, you see the ground truth sequence. And this matrix is added distance matrix.
In progress.
Yes, so and what we're interested in is, for example, if we have generated this SAT, we need to somehow define to tell the model the set of tokens that should be generated next to like continue follow the ground truth trajectory. And they said in this paper that optimal completions can be determined based on the added distance, and optimal completions are determined in such a way that added distance between the generated sequence and between ground truth sequence is minimized. If you go into the details how it is done, basically, if we consider this prefix SAT, no matter what token we generate next, the result in added distance is lower bounded by the minimum added distance in this corresponding row because of how values of the added distance matrix are calculated. Because when you do dynamic programming, the values in the in added distance matrix are non-decreasing, meaning that they also showed that the best case scenario is will be for the following generated sequence to have added distance, which is like this minimum number in this row, meaning that for this particular timestamp, you need to follow the next token, which corresponds to the minimum values of added distance. So in this case, these two, you need, so for each minimum value in this row, you follow the next token. And you end up with a set of optimal completions based on like during this timestamp. Yes. So basically, we can define a policy which should potentially help in dealing with errors in reconstruction. And we can then use policy distillation approach to optimize the alternative objective functions, meaning that we like to find the embedding, which minimizes added distance between sampled sequence and ground truth sequence. And we now train only on the prefixes which are sampled by the model, and ground truth sentence is only used to compute the sequence of optimal completions. So basically, what has changed is that we now, when we do training for this embedding, we use the tokens which are generated from the model, and we minimize the KL divergence between the probability distributions of the model and the set of optimal completions on this particular timestamp. And research questions are the following. So first question is, how well and easy does this initial approach of steering work? Because there is no code associated with this paper, and we wrote to the author of these papers, and he said that the code is lost. Second question is, and he didn't follow up. Second question is, what is the quality of the result in embeddings, and how do they compare to traditional approaches? And third question is, how can the problem of reconstructing longer sequences may be addressed, meaning that, or more precisely, can this optimal completion distillation help or not? Now for the experiments and results. Yes, so initially we wanted to try the transformer architecture, but for some reason we failed to reproduce the results mentioned in this paper. So we downshifted to LSTM architecture. Basically, it is like simplest possible LSTM architecture. You have tokens which are converted to dense representations, and you have LSTMs, and you have projection layer and softmax. And as for the steering vector, we suggest like injecting it like three locations. First location is injecting it before doing projection at every timestamp, and second and third injection locations are like the first uh, hidden and cell state of the LSTM language model. Yes, so we to estimate the quality of embeddings, we first need some language model to test it on. So we decided to train our own language model on a Pantry Bank dataset, which is just a dataset of movie reviews from Wall Street Journal. Um, yes, so basically this is like the best experiment we get. We use only one layer. That was a question from reviewer, only one layer, because we observed that increasing number of layers doesn't help in generalization, and we also needed to drop out and weight decay, like L2 penalty, for the model not to overfit. Basically, that's all. And to understand how the reconstruction is going, we suggest the following matrix. So first is a perplexity, but when conditioned on the embedding vector. Uh, if you think about it, because we train embeddings in such a way, this matrix should be lower than a general perplexity, because for each sentence we condition um, the sentence on its embedding. Another metric is exact match. So basically, we go through each timestamp and calculate whether the generated and ground truth token is the same. Third metric is blue score. So it measures the precision of n-grams in the reconstruction, and it is less forgiving to some changes in the reconstruction. So it allows for some fluency, but also it penalizes for accuracy. And the last metric is prefix match, meaning that it just measures the length of perfect prefix which was reconstructed. Yes, so here are some of the results. So in order not to be not to look so scary, we just we experimented with different optimization procedures. So just maximum likelihood estimation versus optimal completion distillation, and we experimented with varying the locations of the injection. And from this, we see that this OCD approach does not like improve this reconstruction matrix, basically. The results are the following. So OCD, first observation is that this optimal complete distillation requires a lower learning rate and more epochs to converge because of its nature. Secondly, um, this optimization procedure does not improve reconstruction matrix out of the box, and it requires more time to train as compared to MLE. And to estimate the quality of the resulting embeddings, we cross evaluate them on SST2 and SNLI. So basically, SNLI is textual entailment, and SST2 is semantic analysis. And unfortunately, we see that the mean pooling of the hidden states still beats this steering embeddings, and these steering embeddings compare to max pooling of the hidden states of the model. Yes, so answering these research questions, we can say that how well easy is this approach work. It is not easy, definitely, because it might fail. And for transformer, we didn't succeed. And injection locations impacts greatly impacts reconstruction matrix and quality of embeddings as well. For the second point, we did not evaluate this on many data sets, so we cannot provide a definitive answer on the quality of embeddings, but from our experiments, the performance seems similar to just max pooling of the hidden states. For longer sequences, we saw that this optimal completion distillation does not work out of the box and need like further tweaking to this objective. So as a future work, we suggest exploring exploring alternative injection locations, meaning that, for example, we can try adding these hidden states at every timestamp as it is done in original paper, and we have done it like a few days prior, and it improves reconstruction matrix further. Then we may consider altering this OCD objective in the sense that we may consider combination of maximum likelihood and optimal completion distillation. And we can also try evaluating this embeddings in more data sets. We can try, again, steering transformers. And the last point, what we can do is try to directly optimize this optimal completion objective function, but it needs further mathematical derivation in terms of how it can be done. Yes, and yes, that's my last slide. It's like already exactly like 10 seconds to 25 minutes, so I'm on time.
Start? No one. Okay, then I will start. So first comment is that today is June 7th, 7th of June, not April 29 on your
Sorry.
first slide. Um, so, and I'm curious, so does your research like tells us any signs of life of this steering approach at all? So should we invest more time in doing it, or like it just basically doesn't work and we should find any other solution um, to do this like representation vector learning?
Yes, thank you for the question. Yeah, so in this paper with the transformers, they observed perfect reconstruction for smaller sequences, and they evaluated. So they took BERT transformer and they compared it against glow embeddings, and they said that these embeddings a bit like perform on the similar level. And as for this approach in particular, I think that in order for it to be justified, like the objective should be a bit unique because it requires like a long time to train compared to just averaging the hidden states um, of the language model. And we also observed that this optimal completion distillation works even slower, mainly because we need to do sampling. And at first, sampling seemed like it's not that a big deal, but then it seems like we still need to do the projection, meaning that we need to multiply this sampled token with the projection matrix, and we cannot do it in parallel, which means that we lack parallelism in this multiplication, and it further slows down the training as well. And what also slows down the training is the fact that this eddy distance should be matrix should be calculated, and for now we do it on CPU, meaning that on every iteration you need to like pass the data from GPU back to CPU to compute the eddy distance matrix and pass it back to determine the optimal completion, which hints us that this approach is a bit time consuming, and it should be properly justified if you have very like niche problem, so to say. And if we have a very big data set, the amount of time that should be invested, like training time, is very large. So in our experiments, if you see,
Okay,
yes.
I think I'm okay with the answer. Another question is that do I understand correctly? You operate per sentence level, right? So you have one embedding, one final
Uh,
z per vector.
Yes, so we took Pantry Bank, and it was already recognized in birds. We trained a word level language model, and then we, yes. So basically, we train the embedding for the whole sentence with the purpose that this embedding should encode the information which is enough for the language model to reproduce the original sentence. So it means that uh, so our hypothesis was that because the objective function of this embedding aims at reconstructing the whole sentence, the quality should be like better as opposed to just averaging the hidden states, which because a hidden state just is responsible for a particular token, and if you average it, you may end up with like the results of this embedding is not like clear from mathematical perspective.
Okay, thank you.
Uh, Thank you for presentation. I've a basic question, more or less. What was the reason to choose Levenstein added distance as a distance measure?
Yes. So basically, again, we saw this paper and we saw that it fails to reconstruct longer sequences. And so what happened is that so the likelihood of the sentence which is learned by this embedding may be high. But in our experiments, we have seen that when we do greedy generation from the language model, at some point, despite the likelihood of the sentence is the best possible, at some point, one of the tokens differs from the ground truth. And what we have observed is that as long as it happens, further reconstruction just doesn't work. So the reconstructed suffix is completely different from the ground truth suffix. And so basically, it means that as long as language model makes a mistake, it cannot recover with generation. So the objective of this optimal completion distillation is to allow model to generate the token which will help language model to quote recover and continue generation. So if you consider, for example, this example, um, you see that generated is SAT, but you need Sunday. So in this particular case, it's like a bit easy to see that you just need to like forget about these two tokens, and you just need to continue generating Sunday. So you need to generate SAT and then UNDAY. The added distance will be 2. But this, in this particular example, it is easy to see because these two letters are different. Like it is not like almost, if you consider this prefix, they are not present there. So you can just continue with Y and D. But in a general case, it is not like there might be some parts of the ground truth sentence present there, and we need to define an objective on how like we can suggest an optimal completion. And
For that, to use added distance.
yes. So because
why not any other distance function which works well on vector embeddings? You aren't working with strings, as far as I understand. You work with vector embeddings, aren't you?
Yes, so we work with vector embeddings, but when we reconstruct, we work with generated sequence and ground truth sequence. And objective of the embedding is to perfectly reconstruct the input sequence. And we just stumbled upon this paper, which showed that if we consider like added distance, then there is a procedure which will help us, which can determine the set of tokens that are like.
Yeah, but the very same procedure, as far as my intuition says, well, in fact, prescribes that mistake in the L and when it takes the wrong token. If you take another distance measure with the independent components, I mean, for every independent bit in the vector, it might be different. It might be not mistaken when you take the wrong token.
Yeah, I guess my answer to your question would be because we like we have seen that like the exact research. And
So you used the same measure to be comparable to this paper.
yes, and in this paper they showed that when you, if we go like if we throw away embeddings and just train language model, they showed that when you train the language model not with maximum likelihood estimation but optimal completion distillation, it improves the performance of the language model itself. So when language model is trained on the tokens it has generated, then it improves the performance of the language model itself. So that's why we considered this approach.
Thank you.
Can you please answer the question from the reviewer? The third research question was not addressed in neither the discussion nor the conclusions.
Yes. So maybe it was not well articulated. So basically, our question was like, can we tackle the problem of reconstructing longer sequences? And we, in this research, we suggested that this optimal completion distillation approach might help in recovering longer sequences. And we have observed that this OCD objective does not work out of the box. So basically, this research question, maybe we can say that we have tried optimal completion distillations to try to combat the issue of reconstructing longer sequences, but it didn't work out of the box. Why it didn't work? So if we go to the results here, you see that when we train with optimal completion distillation, we have lowered learning rate and we have increased number of epochs. And we did this because we have conducted a few other experiments, and if we use the same learning rate as with MLE, this OCD approach didn't want to converge. And why it is so? Because so if we start training and we initialize this embedding vector with just 0, so we don't influence the language model, it has generated something, and this optimal completion distillation has suggested the optimal completions at each timestamp, and the embedding is trained to learn this optimal completion. But later in training, the generated sequence itself changed because we have altered the embedding vector, and optimal completion also has changed. So meaning that when we do this optimization kind of procedure, we learn some optimal completion, then generated sequence changes. Then we learn another optimal completion. So we learn like a lot of optimal completions which change throughout the process of training. And because we have very few weights in this embedding vector, this optimization problem does not converge. So as the potential suggestion for this problem would be to alter this objective function in the sense that, for example, consider MLE and OCD together. And these are experiments I have done like a few days prior to today, so I didn't include it. So we have seen that, for example, if you weight MLE by 0.9 and OCD by 0.1, it performs similarly to MLE, but I guess it still needs more epochs to converge because it has kind of stochastic nature in the sense that the generated sequences change throughout the process of training, and hence the training as a loss is a bit more noisy as compared to MLE. So maybe this is the rationale behind this. Yeah, I don't know if I answered or not. Okay.
Thank you for presentation. I have one short question. What is the rationale for behind prefix match? Prefix match, you have
Yes,
just a second. For shorter sentences and for longer sentences, the same result doesn't give the metrics how well the model performs. Wouldn't it be better to have a relative prefix match, which calculates the initial part of the proportion of the sentence which was correctly?
Yes. So basically, in the original paper, they did as you like. They didn't do as you suggested, but they considered different portions of the data set. So like longer sequences and shorter sequences. So they observed that shorter sequences are perfectly reconstructed, but they observed that um, mm, longer sequences are like worse reconstruction. But yeah, I think that this metric is still applicable because if you take a longer sequence, it doesn't matter whether the sequence is longer, but it matters like the exact length of sentence that you can perfectly reconstruct. And in our yes, when I was doing like additional experiments, I've seen that, for example, if you use this H and C vectors at every timestamp, it drastically improves like this prefix match metric, which I was a bit surprised. So basically, the answer to your question, yeah, a prefix match cannot be considered as a standalone metric, and you should know the distribution of the length of the sentences in your data set. So for this pantry bank, the mean length of the sentence is, I believe, 18. So these metrics are still applicable to show that there is no perfect reconstruction. I don't know if I answered or yeah. Okay.
Yeah, thank you for your talk. I have very, very short question. I see in this table, like learning rate one in minus first power or one in minus second power, like 10 in. So they're quite high, like large learning rates. Plus, you have really unstandard, no, not standard number of epochs, like 512, 1024. Like usually they're taking like 1000. So is there any motivation behind choosing such kind of parameters, like just high learning rates and not standard number of epochs?
Yes, that's precisely the case. Yes, so basically these are the like the best experiments we had. So basically we did a grid search, and because this problem is a bit different from the language model itself. So language model, like when you train the language model has kind of lots of parameters, and if you set high learning rate, it will like not train well. But um, it seems like the updates. So if you when you start training, we initialize it with the zero vectors, like all these three guys, and we have observed that, and in the paper as well, that in order to influence language model because this is frozen pre-trained, in order to influence language model well enough for it to be able to recover any sequence from the dataset, you need bigger updates. So basically we also tried, as you mentioned, the lower learning rate, but it didn't influence the language model well enough to improve the likelihood of the chosen sentence. And also because you need to train this vector for each sentence, it means that you don't have a lot of time, a lot of computing time, because in datasets you have tens of or hundreds of thousands of sentences. And when it comes to choosing the number of epochs, we also observed that for this particular case, having more epochs does not further improve maximum likelihood. So we tried like different learning rates. We also tried scheduling, like cosine warm up like reduce the learning rates throughout the training, but it didn't like improve the quality, but it took computing time. So that's why we decided to stick with this particular training configuration. And for OCD is different because yeah, I have explained in a previous question why it is so. Yes, so basically also we have seen in the paper as well that this steering vector does not need a lot of epochs if you compare it to language model itself to to converge.
I also have one question. Um, you have mentioned that, for example, for short sentences, it reconstructs it perfectly, and for long, it may struggle with, yeah, with higher error, have you tried to analyze more deeply dependency of target metric from sentence length? Like, for example, to split by different buckets and to measure metrics on different bucket of sentences with similar length.
Yes, I believe we didn't have enough time to do this kind of research, but it was already done in this original paper. And basically, so they calculated this blue score for the different batches of the data set. And similarly to what I've said, they achieved like a perfect blue score for for shorter sequences. And if when the length of the sentence increase, then this metric just drop. So basically, that's what was already reported in the paper, but we didn't have enough time
Okay, I see.
to get this.
Thank you, Yura.
Thanks.
The next student is Ihor Kosovich, and he will be presenting work entitled Evolution of Legislation Topics in Ukrainian Parliament from 2014 to 2023. And he was advised by Yevhen Kostyuk.
Yeah, good afternoon. Thank you for the introduction. So let's go to our plan. First of all, we are going to discuss introduction, then motivation, objectives. After that, we'll discuss related work part. After that, research gap and challenges. After that, data, solution, evaluation, and final results. So in modern democratic countries, parliament is the place where vital decisions are made. In Ukraine, the most important executive body is parliament. Here, politics are accepting different laws. They changing reforms, applying a lot of change, are discussing problems, and some problems are complex that they cannot be resolved really quickly. Some problems can be resolved by several sessions, and it brings us into categorization. So we can split these issues, these problems into long-term and short-term. Long-term persist for years. Maybe some different politics, different parties are trying to resolve them. And short-term can be resolved really quickly with few sessions, few months, and yeah, they are going to find the solution. So motivation is next. As we mentioned, politics can change over time, and it means that it's important to follow a course. For example, if one politic started working on one long-term problems, let's say corruption, it's important that the next politics or the next party will continue his work and not waste all efforts that he was trying to apply. Another part is choice, because voters need to understand some long-term problems, and it will have an impact on their future choice of the next politics. And finally, development. Our international partners want to know how we are developing. Are we resolving long-term issues, these problems or not? Because if we can show that we are good in it, then we can build a good international relationship. So our general objectives are next: to build MML-based algorithm to extract long-term and short-term topics from the parliament discussions, and to create method to compare news and the parliament topics. Particular objectives are to prepare the data set, to apply topic modeling, to create the algorithm to group long-term and short-term topics, and to create method which will compare news and the parliament topics. In the related work section, we want to show a few works. First work was focusing on creating corpus-based approach to the Ukrainian political discourse. The author was trying to analyze which engrams, which slangs were used by politicals. Second work was trying to create to analyze sentiment, opinion, and polarity in United Kingdom Parliament. And the last work was trying to analyze bilingualism in over 3 decades in Ukrainian Parliament. So how politics were speaking, how they were switching into different languages, how they were mixing it, and so on. But our work is another, because we are focusing mainly on topic modeling in the Ukrainian Parliament. Research gap and challenges are next. Lack of topic analysis of Ukrainian Parliament. Also limited analysis of post-2014 parliamentary discussions in Ukraine. Next is lack of long studies for Ukrainian parliamentary topics. And finally, gap in compression between parliamentary discourse and public interests. So let's discuss our pipeline. First of all, as input, we are going to receive PDF transcripts. PDF transcripts contains information which politics were talking about in their sessions. It contains speech, debates, conversation, and etc. After that, we are going to preprocess text, remove any useless information. Then we are going to group this preprocessed text. It's an important step, so we will discuss it a bit later. But in short words, we are not interested in analyzing in topic modeling just files by file. We are interested just in groups. Then we are applying topic modeling, and we get topics from this. And finally, we are going to create apply topic similarity grouping, which will return us long-term or short-term problems. So let's start with the first phase of our pipeline. So we took the data from the official web portal, Verkhovna Rada. It contains PDF documents with transcripts which took place in the parliament. Yes, so basically its structure is on the right side. Next, we are going to preprocess this text. First of all, we are converting this PDF to text using PyPDF library. After that, we are removing headers, footers, plants. Then we are applying tokenization and lemmatization using Stanza library. And then we are removing stop words. For stop words, we used already predefined list of stop words. But we increase the size of the stop words list using TF-IDF word frequency in order to avoid some words which will add noise for us. For example, it can be words or it can be engrams like "Шановний депутат", "Шановний колега", "Parliament", "Верховна Рада України", and so on. Also, we are removing punctuation, and finally, we have preprocessed text. Statistic of the dataset is next. Total number of words is approximately 8.7 million of words. Total number of unique words is approximately 265,000. Total number of lemmas is approximately 6 million, and total number of unique lemmas is approximately 195,000. So let's talk about grouping. So idea under grouping is to merge these transcripts per period with respect to the number of sessions. Why we are not considering just to use simple session? Because when session varies, and it means like some session can last for the whole day. Some session can have the duration just several hours. And with this information, it will be hard to determine which amount of topics were discussed in the parliament. If we will consider too big period, like it will cause a problem because then we can categorize like all problems, they are short term. That's why we decided to split something to similar like period, but with respect to, for example, to vacation period in August, common practice to maintain work balance. And for example, in December, it was noticeable during all years that in December it has bigger amount of session due to ending the year and trying to finish all deadlines and to accept the budget for the next year. So we divided into 4 groups, and then we are applying topic modeling. So what is topic? Topic is a collection of words that frequently occur together. For example, we had 2 categories. One is cat related, another is dog related. So it will have high probability. If we can see like birds like kitten, meow, milk, close, then we can classify it to cat related groups. And if we can see dog-related words like puppy, puddle, bark, bone, then we can classify this into dog-related groups. For topic modeling, we're using LDA. So LDA is a generative probabilistic model of a corpus. It has a parameter like alpha, beta. One is important for per document topic distribution. It control distribution of topics in document, and another is per topic word distribution. It controls word of a topic, word in a topic. Also, we have mix of topics in documents. We have observed word, and for which this word is assigned. So in simple terms, what is LDA? We randomly assign a topic to each word in each document. After that, we update the topic assignment for a single word in a single document. Then we repeat step number 2. And finally, we are getting with iteration better topics. To evaluate the model, we were using coherence score. The idea under coherence score is to show that words that are returned by the model fit together. High coherence score mean that it's more meaningful topic, and we can easier to interpret them. Lower coherence score, the opposite situation, less similar words, and it is more difficult to interpret. So we had group text. We applied per period this group text into LDA model, and we had topics per period. To find the optimal number of topics, we were experimenting with different topics amount. We started with 2, finished with 50, and mostly we were selecting the high coherence score in order to find the optimal amount of topics. But in few cases where, for example, the best coherence score was in 45 topics, but there were no huge difference between the second topic coherence score, which was like, for example, 22 topics. Then we were selecting the second result in order to avoid noisy and better interpret the results. Finally, we are going to topic similarity grouping. To use this, we were using fast text embeddings and Hungarian methods. So what is Hungarian methods? It's a way to split, for example, 3 tasks between 3 workers, but with the most optimal way. So each worker will have just 1 task, and in this case, the minimum price for this task. After LDA topics, we had this words which are displaying this topics. We are applying fast text embeddings. Then we are calculating pairwise cosine similarity. If topics differs in amount of words, then we need to also apply padding in order to make matrix square. After that, we are applying Hungarian methods. Hungarian methods here tries to find best matches between words based on their similarity. And finally, we will have a score average, something like average score of the similarity. And if the score is bigger than 0.4 or equal to it, then if this threshold was empirically defined, then we are merging this groups into one group, this two set of words into one group. Example of similarity grouping which was merged together. It was based mostly on the words like health, COVID, medical, doctor. Yeah. So after that, we are going to classify groups into long-term and short-term. Long-term groups contains more than two topics and it's appearing in multiple periods, while short-term groups contains just single or, for example, two topics, but it's appearing in one period. It can contain different topics, but appearing in one period, then we will classify it as well as short-term problems. After that, we are trying to convert these topics into human readable format. To use it, we're using Llama second version. When we are starting experimenting phase, it was the newest version, and that's why our choice was second version. So our group topics are going to Llama model. Then also we have written the prompt. After that, we received a generalized topic of it. So here is the list, is the histogram of long-term topics. The most occurred topic was education. It faced approximately 12 times. Then life protection, finance, social political reform, healthcare, corruption, defense, and so on. The longest topics that were discussed is defense, safety, approximately 7 years, then education, construction, social political reform, Kyiv, which lasts for 6 years, and finally corruption, almost 6 years. Here we can see that timeline when it was started and when it finished. For event analysis, we selected, for example, one short-term problems, which was gambling business. It was characterized with the words like gambling, game, money, casino, business. This topic faced in summer 2020. And what is interesting in news, we found that in September 2020, Commission for Controlling new like part of Commission of Controlling Gambling Business were created. For long-term topics is considered, for example, like COVID. It was characterized with the words like coronavirus, medical protection, and health. It was classified as long-term topics because it was faced in different periods in our analysis. Next step is for correlation pipeline. For example, we have parliament's data and news data, and we are applying LDA model through this data, and we are getting topics and words and the probability. The same we are applying for the news data. Then we are summing all of the probability of all words. So we will have an array for an array for some period of this sum, and then we are applying Pearson correlation in order to find some linear relationship. And this is how correlation score is calculated. For news data set, we were using a Chromatsky Telegram channel. They started the activity in June 2016. Yes, total number of words is approximately 1 million. Total number of unique words is approximately 100,000. Total number of lemmas is approximately 874,000. Total number of unique lemmas is approximately 70,000. So as we can see here, it is the result of the correlation. Mostly we found strong and high correlation just in winter 19, and Spring 20. Also, it is noticeable that we can see some few moderate and low correlations, but overall, we were not able to prove that parliament and news are highly correlated, and yeah, maybe it should be like due to the reason that this source of news were not displaying just information regarding the parliament data. As a result, we built ML-based algorithm to extract long-term and short-term topics from the parliament discussion. We create method to compare news and the parliament topics, prepare data sets, applied topic modeling, and algorithm to group to long-term and short-term, and created method to compare news and the parliament topics. For future work, we will consider to our analysis not just on the lemma level, but to analyze sentence and speakers, because in this case we can add not just words but context, and to figure out better results. Also, we are going to extend data sets for news correlation and experiment with Glow, for example, and also experiment with different embeddings and models. Yes, also a reaction to the review remarks. Why did you choose to use fast text embedding? So in our experiment phase, we were conducted at the lemma level, and that's why we were choosing fast text embedding, because BERT relies heavily on context to generate optimal embeddings, and using only with lemmas, but might not show us some prominent results. And why not consider the Ukrainian version of fast text? Yes, unfortunately, we skip during our experiment phase fast text by Natalia Romanishin, and we stopped our choice just on the model from the official website for Ukrainian version. Thank you for your attention.
Thank you for a nice presentation. I'm curious about the validity of your topic extraction. Did you have any ground truth to compare and measure the accuracy of topic extraction?
So mostly we were focusing on extracting like this topic, then we were categorizing on these topics into long term and short term. And for example, COVID started appearing in our data from spring 2020. So we were relying on some event analysis when some topics started happening, and we were comparing it with our results for long-term data.
So you didn't care about the names of the topic. You just cared about when it started and when it ended.
No, we care. For example, like in case of COVID, we have the general topic for this general topic, and we were comparing when it was started in our data and when some news appeared in conversations.
Why those transcripts were categorized under COVID, but not, for example, under healthcare?
Because mostly after 2020, it was categorized like a COVID because it was characterized with the words like coronavirus, masks, protection, vaccination, and so on. And that's why it was categorized into a smaller group than more general group to understand what was happening.
Why didn't you do just simple clustering based on embeddings? You clustered your transcripts in several topical groups. You analyzed the conditional probability of the emergence of this or that topic, and then you get the clusters.
Yeah, thank you for this point. Yeah, we will consider later it.
This is the most straightforward way to do this. One more question. why did you base your topic identification on the backs of words and TF-IDF measure?
Because we wanted to generalize topics, set of topics, to have just, for example, general group for it, in order to better understand, not to have a look at these words which were represented by LDA, and that's why we decided to use Llama in order to have the final category.
Oh, just because you had the instrument afterwards. Okay, I do believe that you were looking for this sort of as a title for a topic which makes sense for the grouping of the transcripts. So this title would somehow reflect what were these transcripts in the group about. Is that correct?
Yes.
Was that the motivation, the intention? Well, then why didn't you extract the terms from individual transcripts and group them based on the bags of terms, which are also embedding vectors, in fact? Just use single words.
Yeah. It makes sense, because in this case we also are not relying on the context. We are just relying on the words on the lemma level,
which makes less sense in terms of extracting semantics.
Yeah.
And this is why I asked you at the very beginning why, if there were a sort of a ground truth list of topics in the parliament that you used to verify if your extraction was correct and accurate. So you didn't.
No.
So who believes in your list of topics? Did you show it to the parliament?
Actually, we continue. Like, first of all, we were trying to combine it.
And the reason for asking the last question is that if you do not have ground truth, then you go to the experts and get the experts' interviews and evaluated or validated by the experts' interviews. Did you do that?
Nope.
Okay. Thank you.
Okay, first question, why have you divided timeline into 4 seasons? Why not months? Why not half a years? You could obtain absolutely different result if you make another division.
Yes, so we were going to get enough amount of data in order to get this amount of topics. For example, if we are considering just years, then we can categorize these topics just all as short term, because we will not have enough timelines to analyze as a long term or not. If we are considering like days or, for example, 1 month, then it can contain not much and not enough amount of data. Let's say in August there is gap in sessions due to vacation period, and sometimes in January there is a gap in sessions period. That's why we decided to group it together.
In other words, if you put, for example, September not to the summer period but to the autumn, if I'm not mistaken, how you divide it, so you could again get another distribution.
Yes, but it was like mostly focusing on this gap that in summer period just activity was in June, July, August was missed, and after that September was better grouped to the summer months.
Okay, so
thank you, Ihor. My question, actually a continuation of the question that Vadim asked. Each session has agenda. There are lists of topics to be discussed. That's the obvious thing, to take it and then to compare if for each particular hearing you have identified the topics which were listed.
Yes, it has agenda, but it has like really short version, and it wasn't covered all topics that were speaking during this period. For example, first is like introduction, then one topic which lasts, for example, for 30, 40 pages, and after that another topic. So it's just to general agenda, and while analyzing this old document, we are able to get more topics which were discussed, because they can talk more about different details, not just what was mentioned in agenda.
Okay, thank you. And then the correlation with the news coverage seems indeed very strange to me, because, of course, Parliament has its own tasks. They are discussing legislation issues, and Hromadske is about the life of society in general. So it includes sports, events, and celebrities, news, and so on and so forth. So why on earth comparing these two things?
Yeah, so we wanted to understand, is it correlated or not? Yes, choice of Hromadske can be discussable, but we stopped the choice on the Hromadske because they started the activity in Telegram channel in June 16.
But excuse me, my question is, why at all? What should it give? What scientific or any other benefit would it give? Any insight, information? So why not comparing to some other thing like news coverage in the United States or whatever?
Yeah, so we were comparing because we were. Yeah, I understand your point, but comparing to the news in the Ukrainian publishers makes more sense, because we are trying to figure out maybe there is some correlation. It was like our hypothesis, and that's why we were testing it.
Yeah, I'm sorry, like I'm advisor on this work, and I'm not sure, like, can I add something here, or is it like purely student committee conversation?
Yeah. So maybe after we finish with the question, you can comment.
Okay, thanks.
Yeah, so also I have a couple of questions. So first of all, I'm curious whether you compared your results maybe to other results, not in Ukrainian parliament, but for example, European parliament and so on and so forth, because I just Googled and there exists parliament data set, and it's not only about Ukrainian language, but there are multiple parliament data sets per different parliaments, so on and so forth. And also, for example, I see that there is Voices of Parliament, a corpus approach to parliamentary discourse research. So maybe it's also kind of related. So have you put your work into context with other works and compared somehow?
Yeah, not yet. We have not changed due to time limitation to experiment with another corpus of different languages in order to compare the results and to see how it was interpreted in different languages.
Yes, and also, could you please go to your statistics slides with the distribution tokens, words, sequences, and so forth?
You mean this slide?
No, you were saying about number of tokens, number of statistics of the whole corpus you processed.
Okay.
Oh, maybe this. Yeah, so I'm just curious. I'm just comparing with this Parliament UI to see, because this data set was created exactly for the same years and you could just reuse it, or again, put your work into context with this reprocessing and to compare like what coincides and not coincides. And yeah. So why didn't you took this already existing corpus.
Yeah, we saw this corpus, but when we started like to make a conclusion, to make experiments, to make analysis of it, we already use our approach from downloading and to converting everything. That's why also so we were time limited. We know that this corpus is really good. It contains in XML format every transcripts, every sessions, and it also will be nice to experiment and to compare the results based on this corpus, not just on the pipelines that we suggested.
But you didn't plug in this corpus into your pipeline
No.
to see what.
Yeah, no.
Okay. Questions from the.
Thank you for your presentation. Yeah, it's a good slide to start, I think, my question. So here you have statistics of number of words, but can you please explain, maybe you can give us a number of documents that you have in your corpus, like separate texts?
Total amount of documents was 974.
And can you please remind me how did you split into documents, like on separate text, or you take like the
like how we were grouping it?
No, like you take like the transcription of the
Yes.
whole session, and you use it like as one document, or you split it on some.
Yes. So after we have this PDF format, we are converting it. We are tokenized, lemmatized it, and after that, this is tokenized, lemmatized. Then we are grouping it into groups, which we already discussed. And after that, when we have these groups, we are sending this group into model.
Okay. Yeah. Just as I remember, LDA requires like to supply like separate documents. So yeah, I'm a bit confused. Like if you supply very long text, it might work like not good. And I think I can like continue with the next question. Have you visually at least visually check the results of topic modeling? Because from my practical experience, it really doesn't work. At least on LDA algorithm. Yeah. So have you checked it? Like, does it make sense at least visually?
Unfortunately, no. Mostly we were relying on the context, which we are getting like a general topic for this set of words, and we were comparing this set of this general topic with what happening.
Okay, so you just take like some abstract correlation on your like on your feeling to evaluate.
To evaluate it, we were using like coherence score in order to get the better amount of topics.
Yeah, but it doesn't correlate with some practical metrics that will give you like the quality of your algorithm. So it's like clusterization metric as I remember. So it's like
yeah, we don't apply this.
Okay, and like the LDL algorithm was published in 2003. Is it?
Yeah.
And currently we have like something like BER topic, which is also out of the box. So why not BER topic?
We were experimenting with this BERT topic, but regarding BERT topic, it was mostly, as we started experimenting on the lemma levels without context, BERT topic is better working with context, with this kind of data. And we compared the result for a few years, but coherence score, if we are comparing coherence score of two models, for BERT topic was lower, and sometimes it was returning not meaningful topic for us. For example, it was printing Железняк in different versions, Железняк, Железняка, Железняку, and so on. So we were confused these topics, which were returning BERT topic, and that's why we don't proceed with it.
Okay, got it. And I think the last question, like in your correlation metrics, you have this none like cells. Why it is so?
most of all due to, as we were sending to the BERT topic model, data which without removing stop words. And yes, so maybe it was like correlated due to the reason for this.
Yeah.
Correlation matrix.
Yeah. So if you go to this slide, you can see that you have like none values in this correlation.
Got it. Yeah. Just a second. Yes, so for example, autumn in 2023 wasn't covered in our data. That's why it has none value. Winter and spring was not able to correlate because, as I mentioned, Chromatica started their publishing activity just in June 16. And in autumn, they were not also publishing. So they started just for testing activity in summer. And after that, in autumn, they stopped for a short period publishing. And we were not able to compare it.
Okay, I see. Thanks.
Okay, yeah, I also have a question regarding correlation matrix. Here you presented a Pearson correlation function, and as for me, the correlation could be, but it could be monotonous and not linear. So have you tried like rank correlation, Spearman correlation, other functions?
Unfortunately, no. We just stopped our choice on the Pearson correlation. Yeah, so we didn't experiment with any other types.
Okay.
I just want to proceed with the last question from Vladimir about this LDA justification. So you didn't even, so you answered that you tried this BERT topic, but I didn't find the mention in your thesis.
Yes, we didn't include it because we experimented just with few years, and
so why? So again, the problem with your thesis is that there is no justification for the selected methods. But if you tried, please put this information. It enriches the whole thesis, and it gives the perspective for the reader. And back to the BERT. So, for instance, you could try to train your own BERT model on text of the whole corpus of Parliament text, and then running the topic modeling. And I assume that it would be much more consistent. That's not a just question, probably comment. Thank you.
I think we are done with the question, and Johan, if you want to comment, please.
No, thanks. We covered whatever was on my mind. No, thanks.
Then thank you, Igor.
Thank you.
So we have 1 hour and 4 minute break.